Hey guys, I know period 7 was able to see this example, but we kind of rushed it at the end there. And then period 3, obviously you haven't seen this one done out. So this is number 2 from the PowerPoint that I uploaded into the, I think I put it in the notes folder actually. I'll double check, see if I put it in the notes folder or the worksheet folder. But either way, it's up there. And so let's do it. Okay? So first things first, you got to realize that there's no substitution that you can really do here. There's no integration by parts that you can do here. So you see the factors in the denominator. That's usually a giveaway that you're going to use integration by partial fractions. Okay, so remember, focus on just the integrand here. And we're essentially trying to take this integrand and break it apart. Okay, I can't take the derivative or the antiderivative of this as is. But if I were to cover up the x plus 2, I'd have a better shot. If I could cover up the x plus 1, I'd have a better shot. Okay, there might be some other trickery I would need to do, but it's at least more doable if they're separate. Okay, so this is going to be some number over one of the factors plus some other number over the other factor. And there can be more than two, right? It doesn't matter. We're going to just focus on where they're different factors. There's other tricks when they're the same factor and all these other things. But all we have to worry about are common or uncommon linear factors. So that's what these are. And if we were to sort of, okay, we broke it apart. If we were to kind of put these back together, well, we would need a common denominator, which is this right here. So I'm basically just going to reverse the process of what I just did, which seems silly, but you'll see why in a second. X plus 1. Again, if a couple people weren't here today, so you're seeing this for the first time. Let's see. So this fraction is missing an x plus 1 term. So that's a times x plus 1 plus b times, and this factor, this fraction is missing this factor, x plus 2. And I just put everything back together. But here's the thing. I need to make that, I sort of kind of force that to match what I started with. Because remember, I'm trying to figure out what values of a and b make this true. Well, the denominators are already all set. They're perfect. The only thing I really got to still force is the numerator. So this is ax plus 1 plus bx plus 2b. And the forcing basically comes into matching things up. Apples with apples, oranges with oranges. I have two x's on this side. I have ax and bx on this side. So that means I need my a plus b to equal the 2. Right? I have two x's on this side. I have a plus b x's, if you will, on this side. Obviously, the x's are going to cancel. And then 2 equals a plus b. Or a equals 2 minus b. It doesn't really matter which way you go. But this is important, because now I have a relationship between a and b. Okay? So that takes care of the x's. But don't forget, I still have the 1 to deal with. And I still, oh, was that supposed to be an a? I'm sorry. Ax plus a, right? Silly Robbie, forgot to distribute. Ax plus a. I'm sure you already saw that and you were yelling at the screen and you were ready to like post on Edmodo how I totally messed up and now you don't understand, whatever. Like I care. Anyway, so let's see. So that's ax plus a. And what did I leave? Okay, so I still have an a and I still have a 2b, but there's nothing to match that up on this side. Or is there? Technically, there's a 0 here, right? I mean, there's no... Stop doing that. There's no... Really? Constant value on the left-hand side. So the a and the 2b must equal 0. A and... Oh, apparently I changed colors. A plus 2b must equal 0, but we know a is 2 minus b. So 2 minus b plus 2b equals 0. Just substitute that in. And so what does that give me? B equals negative 2. And if b equals negative 2, then I guess that means a must equal 4. Okay, and now we know what a and b are in order to match it up with what we did here. Okay, let me go over to a new page. Okay, and first of all, I don't even know how I changed the color there a second ago. Let's see if I can figure it out. Ah, there we go. Okay. So, all right, so what did we have? We had a, let me go back. Let's see, a over x plus 2, and a was 4. So 4 over x plus 2. So that integral is the equivalent of 4 over x plus 2 dx. Let me go back. So this integral is equal to 4 over x plus 2 plus b. B is negative 2, so really it's minus 2 over x plus 1. So minus 2, the integral of 2 over x plus 1 dx. So again, just recap. We said that this integrand can be broken up into a over x plus 2 plus b over x plus 1. We just figured out what a and b are. A is 4, b is negative 2. A is 4, b is negative 2. And now I'm essentially just integrating, because this integral is the same as this integral plus that integral. And that's what ends up over here. And this we can do. This is 4 natural log absolute value x plus 2 minus 2 natural log absolute value x plus 1 plus c. Okay? Now, there's nothing I can do to simplify that one because the 4 and the 2 are different, but the first one, if you remember, we did end up simplifying a little. But again, you just look at the choices, right? It's all multiple choice. So, I don't know, what is that? I think that was D. Okay, you guys probably have it in front of you already, but that was, I believe it was D. Okay? So hopefully that helps with number 2 there. And if you need any more help with even the first one that we had done in class, that's fine. I can still help with that. And then I'll make another video showing how to do the third one, just so you have an extra one to look at. Okay, I already uploaded the answer key. And let me know if you need any help. Okay, see you later.